Hello, everyone, and welcome to the fifth installment of our Learning Engineering Speaker Series, where we continue to explore the intersection of human performance, technology, and mission-critical innovation. I'm Stephen Spencer, the leader of C-ADL's multimedia team, and today we are honored to have Dr. DrSummerRebensky. Dr. Rebensky is a senior research scientist at Aptima Incorporated, specializing in cognitive science and human-centered engineering. Her work focuses on adaptive training systems, optimizing learning technologies, and advancing operational effectiveness for the U.S. Air Force and the broader Department of Defense. With a PhD in aviation sciences and a strong background in human factors, she's passionate about bridging research and real-world application to enhance human adaptability and resilience. And today, she will be discussing the methods and considerations for integrating emerging technologies into training environments and the improvements that they can bring. If you'd like to hold your questions till the end, after Dr. Rebensky's presentation, I will pass over proceedings to her. Welcome, Summer, and we're really proud to have you here today.
Awesome. Thank you so much. As Stephen suggested, we're going to cover just kind of a range of topics. I figured it'd be good to kind of talk about a lot of these different technologies that are entering military training for different folks and some of the considerations and challenges that we've seen a lot within some of the work that we do at the United States Air Force, and how to make improvements from there. So this is sort of just a flow diagram of some different topics that we'll talk through today. So how do you actually go about selecting modern technologies, and are they the right fit for what you're trying to train? How do we leverage more cutting edge AI solutions to build immersive training all the way from individual training up to wargaming scenarios? Using all of this data that can now be generated by these modern technologies, how do we collect it in meaningful ways that can be used to train models or get after adaptive training ecosystems? And then lastly, how do we kind of build this full cycle where we're evaluating training, again, also using a lot of AI-based solutions that are out there on the market today. So I'll cover a variety of sort of frameworks that we've utilized within the United States Air Force and some examples of some work and efforts, and I'll kind of talk through lessons learned. At the end, I welcome any questions for going into deep dives. I'll cover a wide range of things, so we'll kind of just go right into it. So first, for selecting some of those modern technologies. Across a bunch of different services, folks have been focused on how do we incorporate things like virtual reality into training. And with the United States services, one of those examples is Maintenance Training Next, where we were able to find that supported some of these evaluations where VR can cut down training time by 50%. However, it did require substantial development efforts, a lot of learning and acquisition of these different technologies. And often what we see across some of the services is that you procure the technology first and then decide how to fit it into your classroom next. And so these don't really change a lot from traditional training content development frameworks and processes, but talking a lot about how do we ground this in a way to understand specifically what parts of training or whether or not your course is a good fit for virtual reality. And so we use this process that we sort of call BOLTS, or Blended Learning Optimized Training Solutions. So with all things in training, starting with those like sort of clear learning objectives of what are you trying to get after, what specifically are you hoping to get at the end of this training, and being able to map through some of these different stages in which you're really decomposing what it is that you're trying to train the trainee and ensuring that perfect fit. And again, leveraging the most out of the technology to inform other parts of the ecosystem like assessment and adaptive training. And so I'll give examples of these throughout each of these stages. So first, for developing clear learning objectives, we have a lot of existing types of documentation that can be leveraged. So for example, career education, field and education training plans, looking at specialty training standards, and there's a wide range of competency models and frameworks that have also been used. A lot, as folks have been trying to move towards adaptive training, we kind of try to keep these a little bit more open, which allows us to design the courses in such a way that they can be adaptive to changes in immersive training technologies. So for example, we might say that we're trying to train a competency of being able to diagnose maintenance issues on an aircraft. While in historic sense, we might be able to say that they can classify specific grades of rust or be able to diagnose specific issues on a aircraft for maintenance issues. However, this makes it very difficult to be agile within a classroom where, if you have reduced training times, to be able to reduce exposure to specific topics. So although those materials might be at a broader or more general level, which allows the instructor to really kind of tailor the material to what they need within the constraints that they have of their classroom, when we talk about how to apply it in the actual immersive training environments, having some of those clear LOs will help us to identify where things like virtual reality might fit in better. So once you have kind of defined down to not just competency level, but maybe proficiency level that you'd like to get out of the training, being able to move into what we call characterizing those perceptual requirements. So virtual reality has gotten very, very popular within things like procedural training or in scenario-based training. So like, for example, sexual harassment training, or being able to talk through how to resolve particular situations, and sort of more communication-based training. And then from the procedural side, things like maintenance and medical have gotten a lot of traction. And the primary reason for that is because they match a lot of these perceptual requirements that VR might afford. So being able to see a variety of different use cases and being able to engage in more normal kinds of conversational aspects within virtual reality. But other things like actually performing the task, you lose a lot of the sensory information, like understanding how much torque it might take in order to attach a piece to an aircraft, or being able to understand when a part might click into place. And so in this stage, what one would do is kind of decompose in order to achieve those specific proficiencies. What are all the different aspects that people might need to experience in order to gain that skill? And then in this task, at the next one, where you're transforming perception to fidelity, actually mapping all of those perceptual requirements to fidelity requirements of the technology. And so within the United States Air Force, we see this a lot of saying, while a Quest headset that's a lower fidelity might be sufficient for instrument level training, that refresh rate is really not going to work for high-end tactical flight training. And so this is where we see some of those more specialty technologies, which can quickly increase your cost for procuring those technologies and for maintaining them as well. In this sort of stage, you might ultimately identify that there's technology that doesn't currently allow these types of perceptions to take place in training. And so that's where soliciting different kinds of solutions or technologies from industry can take place. And in some of these, in mapping perception to fidelity, one might find that specific competencies or skills actually don't need to take place within those virtual reality training environments. So when we talk about a logistically constrained environment, this can really kind of help reduce the amount of content that's within those systems, so you can more quickly turn people through simulation-based training or otherwise. Within this next stage, we talk about optimizing that technology selection. So again, I've kind of alluded to this already, but being able to map some of those different requirements. And in some instances, you might find that VR is a perfect use case. In other instances, traditional materials like a classroom-based learning or a textbook are sufficient solutions. So again, being able to look at these different aspects. And at this stage, you might also consider things like maintenance costs and whether or not at the squadron levels or unit levels that this is sustainable, and the amount of footprint that might be required. So for example, we've been seeing a lot of these lower footprint flight sleds that can fill the same amount of space as one fully immersive legacy projector-based sim. You can fit 12 flight sleds in the same footprint. However, this now changes all of your power requirements because you're powering 12 different simulators in the same footprint. There's HVAC requirements. There's other things like if you're going to be doing night flight training. And in some of the more modern headsets, you can see things like pass-through. But if the classroom or the room is lighted for instructors to be able to walk around, really kind of breaks that immersion with the pass-through of having that lighted room that's coming through the headset, which then kind of adds some additional requirements of being able to do filtering-based systems so that you can merge the physical and the virtual world to give a more realistic training scenario. And then you'll notice here that the last stage is actually focusing on things like developing learning content and assessments. As I said at the beginning, sometimes we find that this is kind of flipped, where technology is procured first and then fit into the training pipeline. But in an ideal world, what we're doing is really identifying all of the different LOs when we're going through things like classroom material refreshes, or building brand new training programs, or trying to, let's say, merge career fields. In the United States Air Force, the concept of multi-capable airmen, being able to see what skills might be able to be trained within the same environment. And by doing this, we can then ensure that what we're doing is assessing learning using immersive technologies, as opposed to the ability to use VR. And that's sort of a message that you'll see throughout some of the discussions in the presentation here today. So after going through some of those foundational things, I'll spend some time talking about what does this look like in practice. If you've decided that certain simulation-based technologies, or virtual reality, or some of this hardware or software-based solutions, if they're a good fit, how can we actually use some more modern AI-based solutions? How can we leverage LLMs in order to build immersive training? One of the biggest things that I like to hit on here is, again, training in VR and not VR training. We often find, I'm sure if any of you guys have had an opportunity to use virtual reality, it cannot sometimes not always be intuitive. Cyber sickness is a real side effect. And so there are a lot of different interaction methods in order to, like, let's say, explore an environment, like going around in a hangar to be able to do an inspection on an aircraft. There are a variety of different ways that one can move around within an environment. So, for example, being able to just press forward on a joystick, and there's this sort of smooth movement that can cause a lot of cyber sickness in individuals. So folks who may have tried VR, you'll notice that there's these sort of teleport systems. So you click a button to then jump to that area, and it can help reduce cyber sickness. The other benefit of this is that we can also reduce the amount of time spent trying to just simply navigate in the environment, which is a real challenge from that perspective. So when we consider implementing VR training at scale, what this means is actually changing the way that we're implementing VR. Often we try to make it a one-to-one mapping of the real-world environment. But in an ideal world, what we're doing is actually leveraging the benefits of virtual reality training to their fullest extent, which in some instances might mean finding the least path of resistance for tackling training. So in this example, if we're trying to actually assess and measure if someone knows the steps that they need to complete for an inspection of an aircraft, one could have an individual use the joysticks to try and fumble and navigate around to the outside of the aircraft, or we can simply prompt them and say, which of the areas would you like to navigate to next, to the maintenance bay or the flight line? And then we can actually use this as an assessment point, which can be used later in other parts of the ecosystem. We're actually assessing the competencies based off the interactions in virtual reality. Since developing a lot of this interaction-based software means that all this code already exists to understand what the next event is. It's just leveraging and exposing that to then also inform things like competencies and proficiency levels as well. The other benefit then also is you automatically transport to the next area, shortening those training times and moving people through more quickly. So doing this just means kind of changing a little bit of how we've been seeing virtual reality implemented so far, but trying to implement content and assessment in a way that is directly tied to those learning objectives, and implementing them in a way where they are repeatable assets that shorten the amount of time as we go from one course to the next. And so one of the benefits of LLMs and some of the more, all of these different AI-based methods that are coming out is the ability to scrape large amounts of information and transform it into different forms in standardized formats that can be leveraged by other systems. So in this example, being able to take existing training content, translating that into things like Excel or CSVs that current instructors are familiar with, and then utilizing other software-based components that can then translate that into pre-made assets in a virtual environment. So when we talk about trying to convert virtual reality at scale across a wide variety of training squadrons, being able to sort of create these sort of repeatable processes will enable us to actually implement a lot of these solutions across multiple squadrons. So I'll go into, this is sort of a like higher level or individual based training example, but I'll kind of talk about how this scales into larger force training like wargaming. So we know that LLMs come out, a lot of them can either focus on scraping text or looking at images or even videos. But we've really been kind of moving towards this area of what's called compound AI. So very similarly to how we wouldn't expect one warfighter to be specialized in multiple different career fields, it's a team of operators that work together towards the mission. Similarly, as we talk about how AI might fit into different solutions, it won't be throwing ChatGPT at every problem. It will be having specialized AI that have been fine-tuned, that have been specially developed for a specific task, and all of those working in concert in an ecosystem in order to achieve an objective. So I'll use some examples as we go along on what this looks like in terms of training content development for some specialized military use cases. So one of those would be the information warfare domain. So how do we train our operators to understand when different information warfare tactics are being utilized, how to generate more resilient information that's going out into the media, into the ecosystems? How do we harden those systems for both training purposes as well as for realistic scenarios that might be utilized for training or for test and evaluation of other solutions? We do so through creating a whole suite of different AI-based components in this sort of ecosystem that represent blue behaviors, red behaviors, that look at scoring and evaluating some of this information warfare content that work in concert to provide a full-up training solution. On the right there, that you can kind of see an example of when we talk about information warfare, one of those biggest pieces is how the population or a group of people might respond to some of these narratives. And so an example on the right is how we create agents that have memory and have particular personality backgrounds in order to create realistic responses to some of these information warfare tactics. So this is an example of how we might create some of those populations. On the left, this is some work we've been doing with DARPA, where you can see a wide variety of different personality traits, different backgrounds that can all impact someone's response to information warfare campaigns. And on the right, you can see an example there of some of the different memory representations that kind of feed a whole suite of agents and their responses to these different information, and then utilizing a method called retrieval augmented generation, which has gained a lot of popularity. It can reference historical research papers, other similar data sets in order to then create realistic representations of how these populations might respond. So how do we understand what their response looks like? On the left there, you can see some links to a variety of different models that assess the content of different people's responses, so you can understand how someone might respond to an information warfare campaign and their emotions, their level of toxicity, their opinions on that. So then on the right, you can see AI-generated content, which is then scored on its weaknesses to information warfare campaigns, such as things like misinformation, and then understanding how populations will respond in a variety of dimensions. What you can see highlighted in there blue would be a different AI that then suggests different areas that can be hardened to then protect that sort of content. So again, this is just an example of how multiple AI might be able to work together to create a training-based solution for information warfare as a domain. What you can see on this slide is a series of fine-tuning that was done. So on the left, what you can see is in blue is a representation of a real-world population response to an information warfare example. The orange dots on top are a ChatGPT model that has not been fine-tuned to that specific use case or to this specific topic. And so in the middle there, what you can see is one that has been fine-tuned off of some historical data. And then on the right is the inclusion of some of those personality and background demographics that we might see some of these information warfare campaigns being pushed to. And so as you can see, as we move from left to right, the AI gets more specialized, goes through some additional stages, and we can see better alignment between those two. Again, showing some examples here of while off-the-shelf models may not directly have a benefit within the training environment, with some small extra steps, they can be fine-tuned to those specific use cases and start to provide realistic wargaming types of scenarios. There's a whole host of papers that anyone can feel free to reach out to me afterwards. I'm happy to provide any of these publications or resources for the team that has been working on these types of efforts. Next, I want to cover, we talked about sort of the information warfare side, but we also have the challenge of, after we move through sort of these foundational training, classroom-based instructions, when we talk about large force exercises, I'm sure folks on the call know this is a very time-intensive task. It's time-consuming, and it often requires a large matter of subject matter expertise or sim drivers in order to build out these scenarios. And as we make changes, those also get time-consuming, and it can be difficult as we learn more about adversary techniques in order to keep these relevant, keep them providing training value to all of the different participants in the environment. And these can often have a wide variety of bottlenecks or challenges. And so how might someone leverage different AI-based solutions that are out there today in order to create adaptive scenarios? There's been a lot of growth in multimodal AI models that are open and available. So being able to scrape things like doctrine in terms of different TTPs that are used across military domains, being able to look at traditional XML code that exists in a lot of the simulation platforms, as well as a lot of pre-made materials that include, mission brief stand-up slides, things like that, to then build, translate using some of those models to scrape information from them to kind of build a structured knowledge database. And then using different methods that I've kind of talked through, like retrieval augmented generation and multiple different AI that are fine-tuned to different aspects. So for example, being able to understand what kinds of competencies might want to be challenged or what different threats might look like within an environment. And then being able to generate a variety of different products, depending on who is utilizing some of these technologies. It might mean creating just a mission scenario event list, or it might mean an actual runnable scenario file, or it might mean briefing materials or scripts, depending on the scale of the exercise and the domain. Often find that it depends on the sort of stakeholder on where their biggest pain point is. But utilizing multiple AI within a system, been able to find can generate and tailor to those specific end users or use cases in order to do so. One of the big important parts of this is that they're validated by SMEs. So in a lot of these solutions, being able to have a feedback loop where then it can be iterated on and refined and changed in order to develop those solutions. Similarly to how we were seeing in the information warfare scenario, what this might look like is generating a whole host of scenarios that then might be have different assessment-based AI that can say, this scenario is really high in terms of the red versus blue threats in it. And so a SME can kind of refine or pick from a library of scenarios in order based on what they're trying to train. So for example, here, being able to say, I'm trying to do a 2v2 dogfight scenario, and really being able to lay out all the different elements that would be required to build this out within a simulation-based environment. This is a small example of within some AI-based systems, how by outlining the different things that I'm looking for and providing some doctrine and TTP-based information, was able to get tabular-based information generated, and then also on top of that, get it to build it in a KML file, which then I was able to import into Google Maps. While this is a simplistic example, when we talk about scale, this could be built in such a way that it could generate full files that could be imported into things like threat generation technologies or simulation-based environments. What we do often find is that in AI-based solutions, as the scenario gets bigger, off-the-shelf models will get a little bit lazy and say, and then you would create the scenario file yourself. So when we talk about scale, what this means is then probably breaking out all of the prompts to be chunk-based so that it's developing different pieces at a time and then compiled at the end into one large simulation-based file. The other benefit of this is also, as I had alluded to, an instructor being able to, or it's me, being able to work with AI-based systems to change one part without impacting the broader scenario design. So then small tweaks could be made to smaller portions of the scenarios, and which I kind of allude to this as Mad Libs on steroids. So being able to use AI to develop things in a structured format in order to meet those different requirements, and still giving the end user the ability to make changes to those different solutions. So next I'll talk about, now if we have immersive content that we're doing, how do we actually collect data out of it that would inform other parts of training? Virtual reality, as we come back to some of these simulation-based environments, virtual reality and simulation environments push an insane amount of data on a second-to-second basis, which can all be potentially leveraged in order to inform things like competencies and requirements. Especially as we consider AI-based models, we're seeing that there's an ever-growing need for more data in order to further improve the AI-based solutions. So how do we actually build or collect data in a way that can inform objectives like this? One of those pieces is being able to provide a diverse amount of data formats and being able to make sure that we're collecting it in a way that it can connect to things like learning management systems and learning ecosystems more broadly, and in a way that we can actually adapt training and aligning it with the evolving needs of different warfighters. So if we're able to then tie different training experiences that an operator might have over the course of their career, we can then train off of that, build models that represent those style of learners, those people of those different backgrounds, which would then allow us to personalize training to similar warfighters that come through the training pipeline later. And then it also, as I've also been talking about, being able to build that continuous feedback loop where we might ultimately define that there's certain workflows, certain training orders, or methods that work better for specific warfighters over others, which really allows us to continually improve the training ecosystem based off of those needs. So I'll give a little example here. Let's say we have two pilots that are first learning how to fly a new platform. We have one pilot who's cool, calm, and collected as they land, and we have another guy who's sweating like the guy from Airplane. Let's say we have primarily just grade sheet-based information. We wouldn't necessarily, although the data looks the same, we wouldn't necessarily say they're both ready to be pilots. So we have a wide variety in modern training systems that can be gathered to really help tease out those that are showing higher levels of proficiency and show experts versus novices. So while in a traditional live fly environment, we might traditionally have just whether or not they were able to complete some of the different tasks, maybe being able to note down different issues that they might have experienced. But traditionally speaking, it's a did they or did they not, and maybe a small scale of how well. But we lack a lot of that more granular information. Some within these sort of newer environments, things that we might be able to pull, for example, is the exact distance in feet from the center line on landing, being able to pull physiological information to understand their workload, and their stress state during some of the training exercises, and being able to understand if they're improving or honing in over repetitions, and again, also being able to look at performance across scenarios. So these are some examples here within traditional observation or grade sheet-based technologies. We might have a checklist for every step they complete. We might also capture some things like how long it took them to complete a task, if they had any errors, or if they needed any assistance. However, within simulation or virtual reality, we can actually uncover each step. So every single object that was touched, interacted with, things that were actually within view, being able to look at specific steps, times, and errors. And this alludes a lot to, as we design the scenario in those earlier steps that I was covering in the presentation, is designing the interactions in a way that they are more robust and more representative of understanding the process and not necessarily having errors within VR. So for example, in a medical-based trainer, we might be trying to understand if a medical officer is applying the right medication. And in a virtual environment, really tiny vials or pill bottles can be very frustrating to pick up. But this is where we can actually break the fourth wall within virtual reality and have someone click on a general area where medications might be found and actually blow them up in size that float in front of the user. And so then when a user picks a specific vial or medication, the chances of them having a user error is quite low. It's more reflective of, if they pick the wrong one, that they have a foundational misunderstanding of which medication to use. So again, being very thoughtful as we try to move towards a more readiness and proficiency-based training systems. How do we design them in a way that can really give us insights into people's competencies and proficiency levels? So those are some examples there. As we consider observer or team-based measures, often we might see behaviorally anchored rating scales or event-based assessments saying, let's go and review when a particular shot occurred, or when we lost an asset, and let's talk about what happened in an after-action review. Within simulation-based environments, we can scrape information like chats, or being able to do voice-to-text or radios in order to create network diagrams. So we talk about team-based communications. Were people talking to the right people at the right time based off of what was happening in the environment? Very complex information, but all of that is happening within the simulation environment that can be tied to each other. And then also similarly, any of their interactions or positional eye data. So if people need to be monitoring specific systems at specific times, a lot of eye tracking based technology already exists within virtual reality headsets in order to calibrate the lenses to their eyes. So actually being able to just tap into that to be able to understand where they're looking and why. And then that same kind of technology can be used to then replay and give the instructor more information than they would traditionally have. So for example, in pilot training, instructors will often squat down, get close to the student's shoulder to understand where they're looking, but instead they can, from an instructor station, really kind of see where they're looking and offer that feedback real time or even remotely. So I'll give some examples. This is a simulator that was made in virtual reality with the United States Air Force Gaming Research Integration for Learning Lab. And so within a emergency parachute-based simulator, you might have a variety of raw data parameters. So for example, looking at environmental conditions. So like the weather that there's...
I left you a note on your desk.
Thinking about hot mic, if someone can mute.
Sorry, someone on mic.
No worries. So I'll have a wide variety of raw data parameters. So for example, weather, landscape, and wind speed and the time of day. And so what we might be able to look at is what kind of conditions were they exposed to in a simulation environment and track that over time. Once they actually go to do live parachute training or actually go out into the field, we might be able to look at transfer of training and see how quickly they pick up from the simulation-based environment to the real one. And we can identify what kind of configurations. So for example, if we have crosswinds coming from a specific direction that people are really struggling with once they go out in the field, we can then configure or change those kinds of conditions within the simulation-based environment to give more exposure time to that. But we can only do so if we're tracking and configuring those kinds of things within the virtual environment. Some other examples include some of that positional information in order to build procedural skill growth. So for example, we were working with the Cedar School for this, and they had mentioned one of their biggest challenges was that humans' predisposition is to look at their feet on the final 100 feet of descent because they want to make sure that they're landing and putting their feet down in the right spot. But what you should actually do is look out at the horizon to make sure that you're landing with equal pressure on both feet to reduce injury. So what we actually built into the virtual environment, again, is breaking that fourth wall to where if the headset was in a specific position or angle pointed down, then it would actually block out the screen and say, look up at the horizon. And we often find with a lot of those unsafe behaviors, the earlier and the more often that you can intervene and correct it, the better. So instead of waiting until the student landed and the instructor walking all the way up to them and saying, hey, by the way, you need to make sure you look at the horizon, you can fix that behavior in the moment. And then additionally, being able to look at other base performance data and their landing effectiveness. And then later on in the that warfighter's career, being able to understand within specific squadrons, what kind of injuries are they having, and then tailoring that training further down the line. And then lastly, I want to talk about evaluating training. So we've collected a bunch of data. How do we actually inform readiness? So I gave some examples of what we can do from a performance side, automatically from the systems in order to inform not only after action review or immediately after training or a learning management system, but also how it can be used to inform after they leave the training schoolhouses and that whole iterative cycle. What I'm going to talk about here is we often see across military units that they'll go reach back out as people leave the training schoolhouse and understand what kind of challenges they're having, which is traditionally done through either interviews, field interviews, or survey-based information through these sorts of feedback cycles. This is not a unique problem to military. It's across a lot of these sorts of focus groups, interview-based methods, and it can be very time-consuming to take all this very heavy qualitative information to actually drive insights that can drive requirements and change. And so how do we actually quickly turn this around? And at this stage is where LLMs can come back in and help extract some of those insights as well. Not only LLMs, but traditional AI or ML-based analytics that are used on text, semantics, and otherwise as well. So for example, here, this is anonymized from a United States Air Force training schoolhouse. They provided some of their evaluation-based data to us. And so using some different modeling techniques, on the right there, you can see some of the interview questions that are presented as they went to on-the-job training and talked to different squadrons. So what this does is really kind of looks at what is the variety of responses that you're getting. So we can go at this from a purely logistics perspective and make evaluations after training more efficient by understanding what kinds of questions are you asking that is really giving you a lot of insights. And so what we can see here is in the blue, through using some of these natural language processing models, we can see that additional comments, and if you could change one thing about training, what would you change, gives us a wide variety of responses. So we can see the total number of words or unique type topics that are brought up within those discussions. But what we can also see is asking, did you find your VR or your AR training realistic? We often find that those are just responses of yes, I did, or no, I didn't. And so being able to pare this down where someone might be able to, let's say, push a survey to different squadrons to collect a initial pass of information, and where they're seeing a large diversity of responses, then maybe they can do more tailored interviews on specifically those topics. Again, the purpose of this being to very quickly dive into the data and see what you're finding, to then inform later parts of evaluation, but really cutting down this initial step of just trying to get the data in a way that insights can be extracted. utilizing other types of methods that actually pull out themes from text-based environments. So this specific approach, what it does is looks at basically subject, verb, object structures. So for example, being able to say the instructor was good. So you can see some examples here on the right where looking at some of that qualitative text-based information, being able to automatically form clusters. So what we can see here is that there's 4 unique topics that came out, which includes people wanting more in-depth training. And we can see that green circle that's there is close to the orange circle that says repetition and hands-on experience, because both of those are talking about wanting more training. And then a little bit further away from it is that blue circle that says improving training quality, which is still kind of a similar topic, which is why we see that those thematic clusters are a little bit close to each other. But then all the way at the bottom, what we can see is the red-based circle, which is the differences between training and operational equipment. So we really see that there's 4 unique clusters, but this is why we see the distance between those themes is quite far from each other. And so again, what this can do is very quickly tell you from interview-based information or survey-based information, what are those themes that are coming out, and then being able to say, okay, we're seeing a couple of these topics, and then being able to choose one that you want to dive into and see the specific responses to those questions. This kind of, as I've kind of talked through these different topics, trying to show ways that it can be used on traditional approaches that folks might be using today, as well as kind of more forward-leaning approaches that folks might be able to use in the future. And once you kind of develop these clusters, layering LLMs on top to then put it in plain English can be very helpful for this sort of approach as well. So overall, I hope that this was a really good overview for different folks, depending on some of your different use cases or needs, to understand some of the constraints that folks might encounter when trying to incorporate some of these technologies, as well as ways that it can be built within your processes and your pipelines today. What we really need to push modern technologies into the training pipelines today is to start really collecting data at that more granular level, and a lot of that metadata that understands what exactly were they trying to train. As an example I like to use is saying, if, let's say you were driving 30 miles an hour, that doesn't necessarily mean anything until you have a context around that. Was someone driving in a school zone, or were they driving on the highway? In both of those instances, driving 30 miles an hour is not okay. And so how do we actually collect data from these simulation-based environments with that context in a way that it can be interpreted to understand if someone is ready or not? And then building those different AI to be able to ingest different data formats, whether that be live recordings, simulated recordings, event-based data within those environments, and being able to link those to objectives and KSAOs, so that those can not only go to the learning management systems, but immediately to the trainer and instructor to then improve training pipelines. If we do this and sort of build out this data structure, it will enable things for us to be able to predict deficiencies, not only in that trainee's career, but also at the edge, and then inform these sort of longitudinal models that might be able to suggest specific training trajectories, which a lot of this really requires us developing data ecosystems, so government reference architectures, so that people can plug and play different AI-based models or different solutions as they need, as different approaches come out on these different data sets. One thing that I will reference, and I've tried to allude in certain places, that some of this modern tech does have issues. So we do still need to have test and evaluation methods for collecting data on the performance of these different technologies and creating different AI and ML-based methods to both generate and evaluate the quality of the content. And then also being able to develop those policies and ecosystems so that these can be integrated more easily as new approaches come out. I know that was a lot of different topics, but at this point, I'll kind of turn it over for questions if anyone has any.
Okay, if you'd just like to raise your hand, and then we can recognize you and get your questions. I have a quick question just to start, maybe not even be relevant, but when you're training your AI agents, is there any steps you take to ensure that you don't exclude relevant research or end up with research that may be inaccurate added to your models?
Yeah, so one of the biggest things that we do is actually sit down with each of the use cases, really doing a full-up requirements analysis. So for example, most recently, we were looking at syllabus generation. So we actually had to sit down with the folks that would draft out syllabi and understanding when they would go reference specific information, when do they refer to different things, how do they actually come up with different calculations of, like, let's say, how many rides someone needs to do. And that's where that sort of Mad Libs on steroids aspect comes from, where different sections refer to different pieces. And so really building a lot of structure, which is where an LLM might generate that end piece, but a lot of it is traditional or foundational code or algorithms that then will pull a lot of that information. So leveraging the strengths of both approaches.
And just in your data collection and evaluation, looking at success and what successful models look like, what do you use initially for comparison, or at the beginning, are you just collecting data about what the most successful model looks like, or are you taking things from real world scenarios and adding those in and comparing it to figure out what data seems to be most relevant?
Yeah, so generally speaking, depending on the use case, you might use publicly available information. So in one example of the information warfare, we actually trained it up on eating disorders on Reddit, but then providing it additional to then validate that it could, on these very large data sets, could generate realistic population responses. And then taking those same kind of approaches and then applying it to something like the Ukraine-Russia war, and then on a smaller data set once those kinds of foundational approaches have been developed.
Okay, thank you. And we have a question. Commander, if you just want to unmute your mic and go ahead.
Yeah, thank you very much. Summer, thank you for the insightful presentation. That was an outstanding overview of all of the different use cases that AI can support. My question has to do with, in a few years from now, if we have several agents supporting the training system and other HR functions, some agents perhaps built in-house, some agents perhaps purchased from different vendors, how are we going to orchestrate all of these agents together? Mm-hmm. This is a blind spot of mine, and maybe you're going to tell me it's not an issue, technically that's easy, or it is something that we need to start thinking of to make sure that we don't end up with some other form of technical debt. Thoughts?
Yeah. So this is sort of the topic that I was referencing called government reference architectures. So in an ideal world, from a government perspective, it would be identifying what that ecosystem needs to look like. So for example, if looking through requirements analysis, our end goal might be assessing how well a trainee is doing. We know that that's going to require information about the trainee themselves, what all previous training they've had, what type of training they were just exposed to, in what type of training environment, and the LOs that we're trying to get achieved. Those are all five different kinds of inputs that have to go in to that end assessment AI system, which then means the earlier parts or the other parts of that system or AIs will have to output those data pieces into the next one. And so as we consider from a government perspective, that's identifying all those inputs and outputs and putting those requirements. So for example, XAPI being one of those standards for ingestion, which from a government perspective will make it so much easier for you to be able to compare vendors or swap when you need to, or then make an in-house based solution, which really enables these sort of AI T&E environments as well. So in terms of a robust solution, we often find like different vendor solutions, they won't play together nice either because no data, it's sort of a black box and no data comes out of the system, or it comes out in a way that's very difficult for other vendors to be able to interpret. And so really trying to get the industry on these different standards and the government owning the ecosystem where all these things plug in, from my perspective, would reduce the technical debt the most.
Okay, thank you very much.
Okay, and we don't appear to have any other questions, so I think, and we do. So if you want to unmute your mic and go ahead.
To accept all the different permissions, yeah, thanks. Yeah, thought I'd lob one in there at the
it's
end,
a process.
So, yeah. So, hi, Summer. Thanks very much for this presentation. My name is Yeji Adamash. I am a defense scientist at DRDC, Defense Research and Development Canada, which is our single main research agency for defense. I know Aptima has had some engagement with DRDC in the past, so I'm very happy to see that Aptima is still doing good work and building on stuff that I've been tracking that you've been doing in the past. So really good to see that. And in a sense, as far as I'm concerned, you're kind of preaching to the choir in the sense that, a lot of what you talk about is stuff that I've been trying to advocate for myself in terms of the training system here in Canada and the forces. My question's a bit in the weeds, perhaps, but I wanted to get your take on this. Typically a lot of these, let's say, automated instructional systems, intelligent tutoring systems have, there is some kind of instructional module that embodies instructional principles, and there's as you were indicating, some representation of our learning objectives and learning plans are represented or modeled or ingested into the system, however you want to put it. But one thing I've been thinking about a lot lately is the fact that in human-to-human instruction, there's a human instructor that takes all those principles and the lesson plan and turns it into an actual instructional practice, right? So it's not just a matter of the principles getting applied in a theoretical sense. They're they're embodied by a good instructor who also has a lot of experience, has their own social skills in terms of relating to students, and a really good instructor is the ultimate adaptive training system, right? So this is something I've been thinking about a lot: is how do we design these systems to not simply, in a sense, model, represent these principles and these documents, but also the practice of the instructor, and this, in a sense, almost like the social space in which a good instructor is practicing their craft with a student. Or, another perspective might be, well, with a technical, like a training system like this, that's maybe a moot point, and we can move beyond that in some respect. Because, why should we try to just replicate with a machine what a human does, which is often also kind of a mistake in some sense. So, yeah, just wondering if you have any thoughts on that.
Yeah, so I'll say that Aptima's mantra is still to augment the human, not replace them, and just allow the people to be really empowered to get after what they want. Most instructors that I talk to, they have no problem with data entry being taken away from them. That's not why they do it. They do it to get time with the students. And so from your perspective there, a lot of that I tried to cover in some different parts. So for example, in pilot training, being able to use the eye tracking so the instructor can stay at their station and guide and have more confidence on what they're looking at to then be able to give that live instruction. Within the simulation-based environments, if we have the mapping of the LOs, then we can actually create different event tags that occurred where we say like, hey, this would be a really high valuable time for you to spend debriefing. So instead of trying to just load up the scenarios, fast forward to the point in time and then going like, oh, I know that this happened where, a blue entity fell out and I wanted to debrief on it. And they're just trying to find that point, being able to really jump to those. And then from an AI ML perspective, then being able to train up where more black box, more fuzzy, to be able to say like, hey, you often kind of debrief from here. This might be another valuable piece. And then creating those expert models to then also inform junior instructors how to be better instructors too. So I think there's a lot of different points that we could touch there, but that's one way where I see that we're not replacing it, but really kind of empowering them.
Great, thanks very much.
Okay, we're getting very close to lunch. So if there's no one who has any other questions, I'm just gonna look for last hands up. But then I just want to thank you, Dr. Rebensky. That was incredibly informative, and considering that VR and disinformation campaigns are two things that have actually been a concern directly to C-ADL, I want to thank you for giving us a lot of inspiration and a lot of ideas. And thank you for everyone here for all your interest and your questions. And just want to say that we will be returning in January with the launch of the second half of our Learning Engineering speaker series. And I wish everyone a really great day. And hopefully we will see you back in the new year. Thank you very much.
Awesome. Thank you, everyone.